Morning, ma'am. Myself, Arni. My roll number is 2340 My branch is ECE section. My subject is electromagnetic waves and transmission lines, and my subject code is 23ECE401. My topic is UHF transmission lines as a circuit element. The UHF stands for the ultra high frequency. This is my topic UHF transmission lines as a circuit element. Firstly, introduction to UHV transmission lines. The UHV transmission lines is operates within the frequency 300 megahertz to the 3 gigahertz. These lines are essentially for effective signal transfer in various communications systems. Understanding their um, Understanding their characteristics is crucially for designing effective circuits. Basic components of the transmission lines. The basic components is a very well transmission lines is includes the coaxial cables and micro trips and strip lines. Then the transmission lines are structured that carry electromagnetic waves from one point to another. They can be characterized by their impedance and which affects the signal reflection and transmissions. These points also I tell. The primary types of transmission lines is includes as the coaxial cables and the microstrips and the strip lines configurations. The UHV transmission lines components is a key components includes the conductor, dielectric materials and the ground planes. This is the transmission lines figure and this is the tower. We are also seeing this type of picture. This tower and insulators and the conductors and dampers, cross arms and earth wire and spackers. This choice of material is impacts the line performance, includes the loss and bandwidth. Proper design minimization signal is degradation and enhances overall efficiency. Impedances in UHV transmission lines. Impedance is a critical parameter in transmission line design, affecting signal integrity. A mismatch in impedance can lead to signal reflection and resulting in power loss. The standard impedance for most UHV applications is typically 50 or 75 ohms. The transmission line equations. The primary equations of governing transmission lines behavior is includes the telegrapher equations. This is the relevant line equation. Propagation equation here very well gamma is equal to alpha plus j beta. Then alpha is a real take the real equations and beta is a take the imaginary equations and gamma is equal to square root of r plus j omega l into j plus j omega c. Then alpha is attenuation constant plus attenuation factor. Then beta is a phase factor or phase constant and attenuation is a loss of factor and phase is a you can measure the velocity. And characteristic impedance equation is a z naught is equal to square root of r plus j omega l by G plus J omega C. The L is indicates the inductor and C is indicates the capacitor, and these equations is describes the voltage and current propagation along the line and line as functions of time and distance. Understanding these equations is essentially for predicting line performance at various frequencies. Loss of characteristics. UHV transmission lines is experience various losses including resistive, dielectric and radiation losses. Minimizing these losses is crucially for maintaining signals quality over long distances. Designer often selective materials and geometrics that optimizing the radiate trade-off between loss and performances. And electric characteristics of transmission lines. There are two transmission lines and the two wire transmission lines and characteristic impedances. And these are the two are electrical characteristics and construction of lines. And impedance measured at any point on line would be same. Distributed circuit element. UHV transmission lines can be modeled as distributed elements rather than lumped elements Approach allows for more accurate analysis of line behavior at a high frequency. The distributed model is accounts for the effects of line length and relate to the wavelength of the signal. Reflection coefficient and VSWR. The the reflection coefficient quantifies how much of the signal is reflected due to impedances mismatches. The VSWR stands for the voltage standing wave ratio, is a measure of the efficiency of power transfer along the line. A low VSWR is indicates the better matching and less signal reflection. The applications of the ultra high frequency transmission lines is a UHF transmission lines is widely used in televisions, broadcasting, mobile communications, and radar systems. Their ability to carry high frequency signals makes them suitable for a variety of electronic devices. Innovation in UHF technologies continue to enhance communication capabilities. Design consideration is a critical design considerations includes line length, layout, geometric and material sections. Stimulation tools helps predict performance and optimize designs before physical implementation. Good design and practice contribute to reliable and efficient communication system. Future trends of UHV transmission lines is the advancement in materials as manufacturing techniques are leading to improve transmission lines performances, and emerging technologies such as 5G and IoT and demand higher frequencies and bandwidth capabilities. Continued research will drive innovation that enhance the effectiveness of UHV transmission lines. These are the IoT technology trends. My topic conclusion is UHV transmission lines are vital components in modern electronic component system. The understanding their properties as circuit elements is essentially for effective design and implementation. As technology is evolved, so will the strategies for utilizing UHV transmissions lines in various applications. Components of a transmission lines is insulators, wave trap, others, hardwares, and vibration clampers, connectors, etc., conductors, and earth waves transmission towers. This picture also is seen. Thank you, ma'am.